Hi everyone, welcome back to the channel. Let's go ahead and continue the series and have another competitive programming walkthrough. Okay, let's get right into it. We've got our screen up. This is CodeChef again. This is another one of the CodeChef problems. This one's slightly more difficult than the last, so we'll jump right into it. It's a very short problem description, so go ahead and read that. So Byteland is our new location, I guess, but this monetary system looks like it's our problem. So it says each Bytelandian cold coin has an integer number written on it. A coin n can be exchanged into a bank for 3 coins, n over 2, n over 3, and n over 4, but these numbers are rounded down. Banks have to make a profit. Awesome. You can sell Bytelandian coins for American dollars at 1-to-1. But you cannot buy Bytelandian coins. Okay, so you have one gold coin, which it seems like has some integer written on it. What is the maximum amount of American dollars you can get for it? Okay, so we've got an input here. Let's look at our requirements. We've got no more than 10 test cases, and the numbers range from 1 to a billion, from 0 to a billion, which is great, awesome. So we're gonna have to be careful with the numbers we use. It is the number written on your coin. So for each test case, output a single line. So for 12, you get 13. For 2, you get 2. Now let's look at their example for that output. You can change 12 into 6, 4, and 3, and then change these into 6 plus 4 plus 3 is equal to 13. If you try to change gold coin 2 into 3 smaller coins, you'll get 1, 0, and 0. Okay, so if you get zeros, you're obviously losing money. There's also potential that you'll lose money if you get some sort of fraction, you get a half or something like that. But let's get into some examples here. I'm gonna draw this out as per usual. Let's see, so we've got 12 here, and that turns into n over 2, n over 3, n over 4. 12 is actually pretty convenient because that divides pretty evenly. So you've got 6 plus 4 plus 3 equals 13. That's what they explained. Let's give another example of something less than 12 to help us understand. 10, and then obviously we've got our same values here. Excuse my handwriting, please. But we're looking at 5 and then 3 because 10 divided by 3 is 3.3, and we're removing any of that remainder, so 10 divided by 4 is going to be 2. So that's not as great. We're looking at 10, so we didn't save any value from that. Would 11 have given us anything different? I don't think so, because we're looking at 2.5 and then 3.3. So it looks like, to me, anything less than 12, or anything that is not divisible by both 2, 3, and 4, we're going to end up with either zeros or fractional values that are going to give us less than the actual number. So we're definitely starting with at least 12. So we want something that is greater than or equal to 12. And let's get into the code a little bit to see what that would look like. So first we're going to say, okay, it's not giving us a value this time. And very common in coding competitions, they will give you either a value at the beginning to tell you how many test cases to run, or they'll just require you to run through as many times as you can. So instead of this test situation we've got here, we can still see in our number, but it's going to be more like this. While we can see in that number, which is a long int, we're going to perform some sort of calculations, and at the end we're going to give ourselves a little end line there. Now at the beginning, after we've taken in a number, we want to create a couple things. We want to create answer, and we might have to create a couple other things along the way. But what we're gonna do is, it looks like, let's say we had one that 12 is gonna be the value here. It sounds like you can keep going, you can keep dividing the coins as much as you want. So let's say we're working with 24. We're gonna say n over 2, n over 3, oh wow, n over 3, and n over 4. Yikes, okay. We're looking at 12 plus 8 plus 6. That here, we know that can become a 13 if we turn it into a 6, a 4, and a 3. So at the end of the day, we're getting 13 plus 8 plus 6, which is going to give us significantly more. It's going to give us 27, it looks like, which is a lot more than 24, and even more than if we had just done it once. So welcome to recursive functions. And if you haven't used them before, they're very exciting, but you have to be very careful with them. Essentially, the concept is You're taking a function and you're running that function from within itself. So let's give a quick example. We know we're going to need something like this. We want to return a long int, and let's call it divide. We're dividing our coins. So we're going to see in also an int, so let's call it the start. And you take that start and you're going to divide it by 2, 3, and 4. But you also need to be aware that if those numbers also divide by 2, 3, and 4, you're going to have to continue running that function until you're done. So let's start with a temporary value that we're going to use. And let's say we've got our start value and then we've got our temp value that we're going to change based on the division. And then we're going to see which one of those is larger. Because in some cases, I'm sure you could come with a value that does divide by these numbers, but also would give you some fractional, and you would lose that because we're not taking any remainders. We're apparently paying those straight to the bank. Okay, so the first thing that we're going to need to do in this recursive function is give ourselves a break statement. So something that can pull us out of this recursive function when it's finished, so that we're not in a continuous loop. That's probably the easiest thing to fall into when you're starting to write in recursive values. So we've got our first if statement. So if, I think we decided it was 12, right? So if start is less than 12, whoa, yikes. We're going to want to return that same value, obviously with the semicolon. Else, we're going to want to give it a division value. So both, we're going to want to first do this temp thing. And now I talked about the recursive value. So we're going to run that recursive function from within itself. So first we're going to want to do the n divided by 2. So start divided by 2. We're also going to run the divide function on start divided by 3. And then we're going to run it again on the last value, which is start divided by 4. Now we're going to get some value for temp. We also need to run a quick check to make sure that that is the largest value that we can get. So we're going to do a quick max, and we're going to say return the greater, so max of temp and start. So whichever one is greater, it's going to return that value. And then answer equals number, or divide of number. So what we're doing here is we're taking in a number, that's number is 12 in our example here. We are plugging it into our divide function, and if it's less than or equal to 12, so it's not going to run that at the beginning, but it's going to pull in and see divide of the start divided by 2, start divided by 3, start divided by 4. If any of those values are less than 12, like for example a 6, 4, and a 3, then we're going to use those instead of running this function over and over and over again, and it should return what we're looking for. But I'm not 100% sure that this max function is in there. It may be, and correct me if I'm wrong here, but I'm just going to run a quick ternary. Let's see, if I want, if A is greater than B, I want A, otherwise I want B, the end. Okay, so let's try this with some custom input. As always, I try to run the input to the output exactly as they have it, just to make 100% sure. Sometimes there are compilation errors, you miss a semicolon somewhere, happens all the time, and I'm assuming we're going to get a similar problem here. I don't know how many times, I could probably count on one hand the amount of times that I'm able to run it right off the bat without any sort of errors. So a lot of programming and coding is going to be fixing small errors along the way. But that's why we have modern compilers, modern debuggers. So once this queues, we will go ahead and continue. Okay, so it looks like now we have our function executed, and that took a really long time. So good thing for video editing, that could be really quick. We have our 13 and our 2, so it looks like we're good to go. Now, there could be other things that are involved, maybe like a time limit exceeded, or other things that we don't realize, because we were talking about numbers up to 1 billion. So let's see what we come up with at the beginning and see what we can do. So we submitted for the first attempt, and like I said, we got a time limit exceeded. So it took us 3.63 seconds. Usually the time limit's somewhere between 1 and 2 seconds. So let's go ahead and see if we can speed this thing up a little bit. So The number one reason that this is probably going slowly is because we have a recursive function in there, and that recursive function is running for every single value. So after a certain point, so for example 12, anything less than 12, we have defined values because we know that those aren't going to be smaller. So what we could do is we could create a subset. Okay, so our subset right now, let's say 10,000. So for the first 10,000 numbers, we're going to create an array that's going to show us what those values are. So for example, for 24, we know the answer is going to be 27. So now every single time that this divide function receives a 24, we know to return 27 without having to run through all of those calculations again. So let's start by creating a little value here. And let's call it our, what can we call it? We could call it reference. We could call it, let's call it memory. That'd be fun. And we want it to be 10,000 strong. And we're going to initialize it just with 0. So all those 10,000 values are going to have zeros. So now we're going to say if, this is an else if, and this value is going to be between the 12 we wanted. So start is greater than or equal to 12, and start is less than 10,000. We don't want equal to because the value, the memory thing is only going to go up to 9,999 because arrays start at 0. So now that we have this, we know if there is a value inside memory. So if memory at this value, and the value is going to be start, and we wanted to say if it's not equal to 0. So we can just leave it because it's initially going to be initialized as 0. You want to return memory at start. Awesome. But else, now this is where we need to, if there's not already a value in there, so this 24, let's say it wasn't there for now, it was blank. We need to go in and add it. So we're going to run the same thing as this, same thing that we have down here. But instead of just returning it, we're also going to save it. So we're going to say memory at start is equal to, now we're going to have this max again here, the max of temp and start. So that way we can save that value and keep it for later. Awesome. So let's see, just make sure that we didn't have any weird compilation errors when we created that, which I already see one. Yep. So we need to make sure we're creating these things the right way. Okay, so now that we've got a successful execution, we can run that test again, and this time we're hoping that using that reference array, it's going to be much faster. So let's find out. Okay, correct answer, and if you look at the time, 0.00 seconds, it ran significantly faster, and I think because most of the values, if they were greater than 10,000, end up running this exact same calculations as the one before them. So we're going at least 10 times as fast by running this with a memory table. So there you have it. That is the answer to this question. And again, a successful solution to the problem, which I'm excited about. Hopefully this was helpful to you. If it was, please feel free to leave a comment down below. We're excited to read those. And if you have any recommendations for future videos, please go ahead and leave those as well. As always, great to have you on the channel. Don't forget to subscribe and like this video, and we will see you in the next one.